edexcel core pure 2 chapter 1 complex numbers mixed example with flag emp. I may skip some questions when it is too repetitive. Let's go for the number 2. So number 2 is here. So this is the induction. So we start with p n. The proposition here, z to the power of n is r to the power of n cos n theta plus I sin n theta, where n include 2z plus. So when n equals 1, LHS is z to the power of 1, which is r cos theta plus I sin theta. And LHS is r to the power of 1 cos 1 theta plus I sin 1 theta, which is r cos theta plus I sin theta. So LHS and LHS are equal, therefore it's true. Assuming that PK is true. So z to the power of k equals r to the power of k cos k theta plus I sin k theta, where k is z plus. So when n equals k plus 1, LHS is zk plus 1 is zk times z. R to the power of k cos k theta I sin k theta times r cos theta plus sin theta I. So r to the power of k plus 1, and I'll expand them with the intention of the first all real numbers, and also after that and imaginary numbers. So cos k theta cos theta minus sin k theta sin theta plus I cos k theta sin theta plus sin k theta cos theta. So r to the power of k plus 1, co comma sin is the compound angle identity of cos addition angles. So cos k theta plus theta plus I saco cosa is the addition compounding angle of the sine. So sine k theta plus theta. R to the power of k plus 1 cos theta k plus 1 theta plus I sin k plus 1 theta. So it's true. Since P1 is true and PK plus 1 is true when PK is true, by the principle of mathematical induction, Pn holds for n z plus. So that's it. And the next one, number 5. So yep, let's go. So this is the one, cos theta plus I sin theta. Cos theta z to the power of n is cos n theta plus I sin n theta. 1 over z to the power of n is cos n theta plus I sin n theta. So when we multiply the cos n theta minus I sine n theta on both sides, because this is the product of sum and difference, so it's the difference of two squares. So squares minus squares, so now turn to plus because we have I squared, sine squared n theta, which is 1. So cos n theta minus I sine n theta. So z to the power of n, 1 over z to the power of n equals cos n theta plus I sine n theta plus cos n theta minus I sine n theta. So 2 cos n theta. Number B. Z to the power of z squared over 1 to the power of 3. So when we I'll solve this with two different methods. The first, not different method, like just from here, because z squared plus 1 over z squared is 2 cos 2 theta cube, so 8 cos cube 2 theta. And binomial expansion 1 3 3 1, so z to the power of 6 plus 3 z to the power of 4 1 over z squared, 3 z to the power of 2 1 over z to the power of 4 1 over z to the power of, oh my god, 6. So z to the power of 6 1 over z to the power of 6 plus 3 z squared 1 over z squared. So they are together, they are equal. So now we can make number C, cos to the power of 3 divided by 8. So this one goes to 2 cos 6 theta plus 6 cos 2 theta. So now we divide by 8, 1 over 4 cos 6 theta, 3 over 4 cos 2 theta. So when we integrate it from pi over 6 to 0, so integral 0 to pi over 6 cos cube 2 theta. So now we can use 1 over 4 cos 6 theta plus 3 cos 2 theta. 1 over 4 sine 6 theta over 6 plus 3 over 2 sine 2 theta. 0 to pi over 6. 1 over 4. 0 because it's sine pi plus 3 over 2 sine pi over 3 minus or 0. So now 8, 16, 3 squared to 3. And the next question. Number 6 is the same. It's just power of 5. So far it was power of 3, but now you can make it power of 5. Like z plus 1 over z to the power of 5. And you can do the very same thing there. Then you will find it. Number 7 is same also. So I will skip it. And number 8 is different because number 6 7 is like power of 6, and now we have all powers 1, like power deduction. But number 8, actually this was number like degree 1, but now we have higher degrees, which means they are different approaches. So sine 6 theta goes to sine 2 theta, 16 cos to the power of 4, 16 cos squared plus 3. So let's go. So sine 6 theta, this is a little bit different approach. Let z be cos theta plus I sine theta. And I will find z to the power of 6 two different approaches. The first one is de Moivre, and 2 binomial expansion. So doom reverse is just simple. So cos 6 theta plus I sine 6 theta. Binomial expansion. This is 6, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. So I need to use this. So cos to the power of 6 theta plus 6I cos 5 sine 1 minus 15 cos 4 sine squared minus 20 I cos 3 sine 3. Now is 4, so plus cos 2 sine 4, 15, minus, plus 6I cos theta sine 5, and minus sine to the power of 6, because I to the power of 6 is I 4 and I squared minus, yeah, this is the one. So now we want to express only sine 6 theta. So it's the imaginary part. So here, here, here. So sine 6 theta becomes 6 cos 5 theta sine theta minus 20 cos cube theta sine cube theta plus 6 cos theta sine 5 theta. When you write the imaginary part, you don't need to write I. Imaginary part doesn't include I. So now we make it 2 cos theta sine theta because we have this one. And cos to the power of 4 minus 20 cos squared sine squared plus 3, this is 10, sorry, 3 sine 4. So sine 2 theta, 3 cos 4 minus 10 cos squared. Sine squared is 1 minus cos squared, which is Pythagorean identity. Cos squared squared. So sine 2 theta, 3 cos to the power of 4 minus 10 cos squared plus 10 cos to the power of 4 plus 3 minus 6 cos squared plus 3 cos to the power of 4. And sine 2 theta. This is 16 cos 4. This 16 cos squared plus 3, which is, yeah, we made it. So the next one, which is number 9, A is repetitive, so I will skip it, but I will go for number B with the result of number A. So find all solutions is let x be cos theta, then 16 cos to the power of 5 theta minus 20 cos cube theta plus 5 cos theta plus 1 equals 0. Then this one is, we know this is cos 5 theta plus 1 equals 0. So now we can find the cos of 5 theta becomes a negative 1. 5 theta can be negative 1 here. So pi, 3 pi, 5 pi, 7 pi, 9 pi, 11 pi, 13 pi, something like that. So now we have 5, 5, 5, 5, 5, 5, 5. But you know pi over 5 and 11 pi over 5 is already same. It's coterminal angle, so we don't need it. And this also. So we don't need the other ones further. So therefore the answers are x is cos pi over 5, cos 3 pi over 5, cos pi, cos 7 pi over 5, cos 9 pi over 5. When you use your calculator, you will find the 3 decimal place answers. Number 10. This is also same. So I will skip the A, but I will do the number B. So sine 5 theta is like, now we know 16 sine to the power of 5 is sine 5 theta minus 5 sine 3 theta plus 10 sine theta minus sine theta minus sine theta, because we have 9 sine theta only. So this becomes 0. So 16 sine to the power of 5 sine theta equals 0. So we factorize it. 4 minus 1. So sine theta can be 0. Or sine to the power of 4 is 1 over 16, which means sine theta can be plus minus 1 over 2. So 0 to pi, sine is like this. Here, here, here. So theta can be 0, 1 over 6 pi, and 5 pi over 6. 1 over 2, yep. And number 11. Yeah, again, repetitive. So let me do number B. Solving the equation. So let's make it B. Cos 5 theta becomes 0. I think I found it. No? No, it was yeah, it was negative 1. So 5 theta can be here and here. Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, blah blah blah. So theta can be pi over 10, 3 pi over 10, pi over 2, 7 pi over 10, 9 pi over 10, blah blah blah. So let's see. So one of the answer can be, so pi over 10 is the answer. So when we plug into the formula from A, then we can find the expression for cos squared pi over 10. So cos 5, 10 becomes cos pi over 10 and 16 cos to the power of 4 pi over 10 minus 20 cos squared pi over 10 plus 5. So this is 0. And this is not 0. We know that. So 16 cos to the power of 4 minus 20 cos to the power of 2 plus 5. So now this is like a hidden quadratic form, so we can use quadratic formula. Cos squared pi over 10 becomes 32, 20 plus minus 400 minus 320. So 32, 20 plus minus 80. So 4 square root of 5. So 8 square root of 5 plus minus 5, 8. We know cos squared of pi over 10 is larger than cos squared of pi over 4, because cos is like this, 0 to pi. So like this. So pi over 4 is 1 over 2, which is 4 over 8. So it should be larger than that. Therefore, cos squared of pi over 10 is 5 plus square root of 5 over 8. And hence or otherwise. Now, let me make it a little bit larger, like this. 0, pi over 2, pi. So now we found pi over 10 here. And we can find that by the symmetricity, this is 9 pi over 10. So this should be exactly the same because it's squared. So plus minus doesn't mean anything here. This is the one. Then cos squared pi over 3 pi over 10 and cos squared 7 pi over 10 should be 5 minus square root of 5 over 8 as smaller than cos squared pi over 4 this time. And number 12. So the Moivre theorem, expression tangent 3 theta. So tangent 3 theta, we need to find sine cos theta plus I sine theta cube is cos 3 theta plus I sine 3 theta. 1331 binomial expansion, cos cube plus 3i cos squared sine plus minus 3 cos theta sine squared minus I sine cube. So now tangent 3 theta is sine 3 theta over cos 3 theta. Somehow the Apple Pencil is a little bit strange now. So sine 3 theta is imaginary part of here. So 3 cos squared theta sine theta minus sine power 3. Cos 3 theta minus 3 cos theta sine squared of theta. So sine theta 3 cos squared minus sine squared over cos theta cos squared minus 3 sine squared. So we can make it consistent. Let's make it only cos theta. 1 minus cos squared 1 minus cos squared. So 3 minus minus 1 plus 4 cos squared theta minus 1. Here minus this 3. What is that? Negative plus 3 4 cos squared theta minus 3. Am I correct? I think so. In terms of tangent theta, sorry. Then I will delete all of this and divide by cos cube theta, everything. So cos cube theta, 3 sine theta over cos theta minus sine theta over cos theta cube. 1 minus 3 sine theta over cos theta squared. So 3 tan theta minus tan cube theta. 1 minus 3 tan squared theta. So deduce that cotangent. So that is the reciprocal. Cotangent 3 theta is 1 minus 3 tan squared theta 3 tan theta minus tan cube theta. So divide by tan cube. Then 1 tan cube theta minus 3 1 tan theta. 3 1 over tan squared theta minus 1. So cotangent 3 theta minus 3 cotangent theta 3 cotangent squared theta minus 1. And number 13. C plus is 1 plus k cos theta plus I sine theta plus k squared cos theta plus I sine, 2 theta, I sine 2 theta, plus k cube cos 3 theta plus I sine 3 theta plus blah 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 blah. So this is 1 plus k cis theta, k squared cis theta squared, k cube cis theta cube plus blah blah blah. So this is infinite geometry series. The first term is 1 and the ratio is k cos theta plus I sine theta. So now we can make the 1 minus k cos theta minus ik sine theta. So we can make the rationalization 1 minus k cos theta plus ik sine theta squared. So 1 minus k cos theta, let me expand it. 1 minus 2k cos theta plus k squared cos squared theta plus k squared sine squared theta. 1 minus k cos theta plus ik sine theta. So 1 minus plus k squared, because this is k squared, minus 2k cos theta. 1 minus k cos theta plus 1 plus k squared minus 2k cos theta is I k sine theta. Therefore, this is C and this is S. And number 14, 4 minus 4i, 4 minus 4i. So this is from the argon diagram. We can tell it's from the origin is 4 square root 2 cis negative pi over 4. And otherwise of the equation, we can make z to the power of 5 is 4 square root 2 cis, just to make it like 2 to the power of square root 2 to the power of 5, is it? Yep. And cis negative pi over 4 plus 2k pi. Let's make it like this. So square root 2 to the power of 5 cis 4 8k minus 1 pi. So z becomes a square root 2 cis 20 8k minus 1 pi. So the answer is should be 5 square root 2 cis negative, when k is negative 2, negative 17 over 20 pi square root 2 cis negative 9 over 20 pi square root 2 cis negative 1 over 20 pi square root 2 cis 7 pi over 20 square root 2 cis 15 pi over 20. So now we have 5 answers. Oh, it says with this Euler form, so that is square root 2 e to the power of negative 17 over 20 pi I square root 2 e to the power of negative 9 over 20 pi I square root 2 e negative 1 over 20 pi I square root 2 e 7 pi over 20 I square root 2 e 15 pi over 20 I. So this is the one. Argon diagram, those roots. So all of them are like square root 2 distance from the origin. And the first one is pi over 20 is like 9. So here square root of 2 e 7 pi over 20i. So here 15 pi over 20 I e square root of 2. And here square root of 2 e negative 1 over 20 pi I. It should be like 5. So not here. It was 9. So here square root of 2 e negative 9 over 20 pi I. So, and somewhere here square root of 2 e negative 17 20 pi I. So it should be look like a regular polygon, like regular pentagon. Number 15, cube roots and represent ABC diagram and ABCM modulus and argument of W to the power of 6. Let's do that. So cube root z to the power of 3 equals 2 minus 2i. 2 minus 2. Again, 2 square root of 2. Cis negative pi over 4 plus 2 pi I 2 pi k. So z becomes square root of 2 cis 12 8k minus 1 pi. So z square root of 2 e to the power of negative pi 2 pi. Negative 2 negative 17. What was it? Negative 2 negative 1 negative 9 12 pi and square root of 2 e to the power 7 12 pi and square root of 2 e negative 1 12 pi, like this. So those are A in the first quadrant. So now we express here this is A, and pi here we don't call it B, ongoing, going anticlockwise, B. So C, what was it? Negative 3, like this. So all of them distance of square root of 2 from the origin. So midpoint of AB is M. M represent the complex number W. So modulus and argument of W. So the because from here to here is pi over 2 pi over 3. So now we have pi over 3. Sorry. Argument of A was 1 over 12 minus pi, and we have clockwise, anticlockwise pi over 3. So 12 3 pi, which is pi over 4. So the modulus argument of M, like W, is pi over 4, and modulus of W is, because now we have here square root of 2, so we know that it's square root of 2 over 2 because of the special triangle ratio, or you can use, we know this is a 30 degree and 60 degree and blah blah blah, so you can use sine, and so this is the one. So W is square root of 2 over 2 cis e to the power of pi over 4i, and we will make it 6. So 2, 8, 2 to the power of 6. So this is 1 over 8 e to the power of pi I 3, 2. So this is from the argon diagram. The distance is 1 over 8 from the origin, and argument is to 3 pi over 2. So this coordinate is 0, negative 1 over 8. So this is negative 1 over 8i. And the last question, number 16. Equilateral triangle has the center at the origin. One vertex is point 2, 1. So coordinate of other vertices. So from here, we will make all same the distance, and the difference of argument is 2 pi over 3. So this one is 2, 1. So actually we don't know what it is. So let's say this one is square root of 5 cis theta. Let's say square root of 5 cis theta plus 2 pi over 3, and square root of 5 theta minus 5 cis theta minus 2 pi over 3. So theta is arctan 1 over 2. So you will find the coordinate of two vertices. So show that length of the one side of the triangle is 15. So now we have here square root of 5, square root of 5, and this is 2 pi over 3. So law of cosine is let's call this A and B, let's say. Then AB squared is 5 plus 5 minus 2 square root of 5 and square root of 5 cos 2 pi over 3. 10 minus 10 cos 2 pi over 3 is negative 1 over 2. So 15. Therefore, AB is square root 15. That's it.